So again, if you need to review any of this at all, just check out the book. Like I said, I'm confident in your ability to plot points. All right. Objective 2 is the distance and midpoint formula, and that I'm going to review, and we're going to do a couple examples. We use this more in geometry. You may have used it in pre-calc if you took pre-calc. So this might not be as distant a memory as some of the other things that we've worked on. But I'm gonna go through an example of a distance formula problem and an example of a midpoint formula problem. And there are some formulas that go with them that we need to have. So the first one is the distance formula, and that's on page 167 in your book, since that's kind of small. But essentially what the distance between any 2 points equals is the square root of the difference in the x's squared plus the difference in the y's squared. Okay, the order in which you subtract doesn't really matter because you're going to square them anyway. So even if you subtracted in the other order and you got, say, a negative number, you're going to square it anyway. It's still going to be positive. So difference in the x's squared plus the difference in the y squared, and the square root of all of that will give you the distance. Okay. Here's the example that we're going to do. So we're trying to find, and part of the reason I'm showing you this problem is the way that the book asks you to find your answers. It says it wants the exact distance, and it also wants you to approximate to 2 decimal places, so we're going to do that. So go ahead and find the distance between -1, 4 and 3, -6. So I actually followed the formula and went x2 minus x1, so in this case 3 minus -1, -6 minus 4, so this is positive 4 squared, and this is -10 squared. Okay, so that is the square root of 16 plus 100. And then, so an exact answer is basically with the radical, breaking it down as best as you can. So is there a perfect square that goes into 116?
4.
4?
Yes.
No, 4 definitely goes into it. Yes, he's right. 4 goes into it. Anything bigger than 4? Well, what's 116 divided by 4?
29.
29. So that's 4 times 29. 29 is prime. So that ends up giving me the square root of 4 is 2. So the 2 comes out. So that would be the exact answer. 2 root 29. Okay, that's the exact answer. It's not rounded at all. Okay. Then to find the approximation, we're talking about plugging this in the calculator and seeing what we get with the decimal. Okay. So we're going to round it to 2 places. And you should have a sense of what number it should be close to, right? Because this is bigger than, the square root of 116 is going to be bigger than 10, because this is bigger than 100, but it's less than 11 because the square root of 121 is 11. So are approximately equal to 10.77.
Which one do you want?
Well, in this particular problem it says both. Give exact and. So for now we want both, and that's one of the reasons I went over this, is because your homework is going to ask for both. Okay? Any questions on distance formula? All right, let's look at one for midpoint formula. And this is on page 168. And the book puts this little avoiding mistakes thing. The midpoint is it's an actual point. Okay? So you need an x, you need a y. It's really just the average of the x's. So the x coordinates added together divided by 2, the y coordinates added together divided by 2. And since you can add in any order, the x1, x2 order doesn't really make that big of a difference. Okay? So the average of the x's over 2, well, the average of the x's, the average of the y's, that will give me my midpoint. And so oftentimes you will get decimals, you'll get 0.5s, that kind of thing. Now, that's when you have integers. You're not always going to have integers either. So here's the example that we're going to do. Okay, so we've got a segment, a line segment that goes in between -1.5 and -9, and negative 8.7 and 4. So go ahead and find the midpoint using the formula. So to find the midpoint, I'm going to add the x's together. Alright, so when I add those together, I get negative 10.2 and negative 5 on top. Divide those by 2, get negative 5.1, negative 2.5. That is the midpoint. So that would be the point if I was connecting the segment that was right in the middle of that segment, okay? So that is distance and midpoint. Pretty straightforward. You guys have done that before, likely in geometry class, okay? Objective 3, I am skipping covering, but if you need to go through it, go through it. It's how to make a graph by generating a table, okay? So if you wanted to make a table of values, x and y, and pick a bunch of values for x and plug them in to find y's, and then plot those points, that's all objective 3 is, okay? You have a graphing calculator, which also generates a table of values for you. Once you have an equation in, you're welcome to also use that. So, again, that's not something I'm going to cover. If you need to review objective 3, go back in the book and look it over, but it's pretty straightforward. I do want to talk about objective 4, however, x and y intercepts, okay? Because I want to review a couple things. One, what they are, what they mean, and for whatever reason, sometimes we have confusion in terms of figuring out which one is which and what they look like and where to find them and that kind of thing. The first group of problems that you're going to look at relating to x and y intercepts are going to be graphs, and they're going to ask you to identify the x and y intercepts from the graph, okay? So if you're going to explain to somebody what an x-intercept was, what would you tell them?
That crosses the x-axis.
Where the graph crosses the x-axis, okay? What would you then explain to somebody if they wanted to know what the y-intercept was? Yes, McKenna?
It's where the graph makes contact with the y-axis.
Correct. Usually it crosses, not necessarily contact, but crosses the y-axis. Now, here's the thing that you need to know. If there's a point that lies on the x-axis, right? That's what we're talking about for an x-intercept. There's a point that lies on the x-axis. What do we know about the coordinates of that point? Y equals 0. For an x-intercept, the y equals 0. For a y-intercept, what do we know about the coordinates of that point? The x equals 0. So we get that switched around sometimes. We get that confused. Okay? And sometimes we put 0 in the wrong place. So, again, the x-intercept is a point where the graph intercepts the x-axis. And so that y value of that point is 0. So it's always going to be in the form x comma 0, whatever the x is. And then all of the opposite is true for the y-intercept. Okay. The x value is 0. And so it's going to be in the form 0 comma y. So again, in your homework, you're going to have a picture of a graph. They're asking you to identify the x and y intercepts. All you've got to do is identify those points, okay, by looking at the graph. Okay. The other thing that you're going to do with objective 4 is use the x and y intercepts to graph an equation. So we're going to go through an example, and I'm going to show you how I like to do these. And I'm going to use a simple linear equation. And so this also ties back into objective 3, picking values and finding the corresponding x and y values to make some points that I can use to graph. Alright, so here's the problem we're going to look at. We've got this equation, 2x minus 5y, and I want you to use the x and y intercepts. Here's the way I like to set these up. Okay, so my x-intercept means that the y has to equal 0. So I can choose a value for x or y and then find the other value by just plugging it into the equation. Okay. So go ahead and do that. Go ahead and find the x-intercept. Plug the 0 in for y and then figure out what the x has to be that goes with it. Alright, what is the x-intercept then? 5, 0. Okay. So I plug 0 in for y, 2x equals 10, x equals 5, so the x-intercept is 5, 0. How many have that? Good? Now then to find the y-intercept, I have to plug 0 in for x. Same process, so go ahead and figure that out if you haven't already. 0, -2. Okay, so those are my intercepts. So once you find the intercepts, then you just have to graph them and connect them. Alright, so that's what it's going to look like. Now, one other thing that I forgot to mention. I think right off the bat, the questions they ask you in your homework are, determine if these points are solutions or points on the equation, for the equation. If they give you a question like that, you take the point that is given, plug it in for x and y, and see if you end up getting a true statement. If it works out, and after you've plugged x and y in, and you simplify and the left side equals the right side, then it's a point on the graph. It is a solution to the equation. If it doesn't work out, then it's not. Okay? So I think those are the first few questions that you have to work on. Again, everything that you need to know is in the book. You can look at it a little further. I know I skipped a few things and went quickly over some of them, but the truth is all of this you've seen before. So if you need to refresh or review any more than what I did with you, it's all right there in the book. Okay?